right, so welcome to lesson 2, and our goal for this lesson is to be able to combine like terms in an algebraic expression. So some really important vocabulary to get started. Like terms. So what are like terms? The lesson is about combining like terms. What are like terms? Like terms are two or more terms considered like if they have the same variable to the same exponent. So for example, x squared and x squared are like terms. 2x squared and 3x squared are like terms because it's the same variable to the same power. Okay? However, something like x plus y, not like terms. X and y aren't the same variable. Something like 3x squared plus 2x are not like terms because one is squared and one is not. So you have to be careful. Same variable, same power. Terms can only be combined if they're like. Constants are terms that have no variables and they're just numbers, and you can combine numbers. So constants can be combined, they're like terms. And then a coefficient is the number in front of a variable or term. So if I have something like 3x, the 3 is considered a constant. All right, so we're going to do some agree and disagree here. What I want you to do is pause the video, take a look, and see if you agree or disagree with the conclusion. I know it's silly with smiley faces, but give it a try. All right, so in this, I know we have smiley faces, but these smiley faces can be like terms, okay? There's one variable, the variable is a smiley face, and there's no exponent. These two terms are both smiley faces, which means we can add the coefficients 4 and 8 to get 12 smiley faces. These two terms are both frowny faces, and they have no exponents, so they're like terms, so we can add the coefficients to get 9 and 3 makes 12 frowny faces. And there we go, 12 smiley faces, 12 frowny faces. This one works. Now, take a look at the second one. For this one, I disagree. We have 2 smiley faces here. Well, really 12 smiley faces, 4 smiley faces plus 8 smiley faces. And we have 9 frowny faces and 3 frowny faces. This is a brand new variable. You can't combine x and y and get z. You can't combine two variables to get a new variable. So no, we don't have 24 of anything here. We have 12 smileys, 12 frowns, and no, we don't have any of these whatever indifferent faces. So this is a disagree. So if I have 3 apples, 5 Twizzlers, 2 bananas, and 1 apple, well, I can say that I have 3 and 1 apples to make 4 apples, but I can't say I have 3 plus 5 plus 2, what's that, 10 plus 1, 11. I can't say I have 11 apple Twizzler bananas. Combining apples, Twizzlers, bananas, and it doesn't make new variables, okay? So we can't combine things that aren't exactly alike. So this is a disagree. Over here, yes, as I said, I can combine the 3 and 1 apple to make 4 apples, and then I just have 5 Twizzlers and 2 bananas. I don't get to combine these to make some kind of new variable. So this is an agree. All right, so now we're moving into the world of variables. In this problem, we have 6 and 12. 6 and 12 are both constants. They have no variables, which means they're like terms. Constants are always like terms. Then you have 6x, which is not a like term to the 6 and the 12 because it has an x. So we can put the 6 and 12 together to make an 18, but the 6x can't combine with that 18 to make a 24x. So over here, we agree. 6x plus 18, you have the 6x and the 6 and 12 make an 18. Over here, we disagree. It doesn't make sense because you can't put the 18 together with the 6x. So let's start doing some real examples. So for this one, I'm going to do the same thing. I have 7y and negative 3y. Keep in mind that's a negative. Okay, those are like terms because they both have a y. Then I have 2 and negative 8. Keep in mind that's a negative. I have 2 and negative 8. Those are like terms because they're both constants. So the 7y and the negative 3y can make a 4y. And then the 2 and the negative 8 can make a negative 6, giving us an answer of 4y minus 6. I can't put the y term together with the constant term, so this problem's over. All right, so this one, I've got a 5x and a 3x. I've got a y, a negative 4y, and a positive y. So all of those y terms can be put together, and all those x terms can be put together. I'm going to put together the 5x and the 3x to make an 8x. I'm going to put together the y's to get 1y minus 4y, that makes negative 3y, plus a y makes it negative 2y. And that problem's done because I can't put x terms and y terms together. Same thing with example 3. So 3x squared and 2x squared are like terms. And it's actually different for negative 7x and x because they don't have a square. They don't have that little 2 up here. So they are not like terms. So I'm going to put together the x squared terms to say 3x squared and 2x squared. You add the coefficients, so that makes a 5x squared. And negative 7x and positive x makes a negative 6x. And we get 5x squared minus 6x. You can't put these together. They aren't like terms. All right, moving on to some fill-in-the-blank question. What I'm looking at here is that I have some x terms on this side and some constant terms, or a constant term, okay? Over on the left side, I can match that 7. I also have a 7, so I'm good. But I don't have 5x, I only have 3x's. So the way we're going to fill the gap there is we're going to add a 2x, because when we put this 2x together with this 3x, we'll make a 5x and the two sides will match. All we're doing with these fill in the blanks, which shows up on the test, all we're doing with these fill in the blanks is putting something there that's going to make the two sides equal to each other. So on this side, I have a 9x squared for number 2, and I have a y. They're different terms, so I'm going to underline each of them. On this side, I have 3x squared, and I'm missing 6x squareds to make it match. So if I give this a 6x squared, now I have 3x squared and 6x squared to make a 9x squared. I'm also missing that y, so I'm going to put plus y, and now the two y's match up. For number 3, this side has a 5x squared and a 10x. On this side, it has a 3x and an x squared. So it's missing 4x squareds. Since the other side has 5 and it has 1x squared, it's missing 4x squared. So I'm going to put a 4x squared. And it's missing 7x's. If one side has 10 and the other side has 3, it's missing 7x's. So I'm going to give this 7x. And now the two sides should match. Finally, number 4, this side has 10 A's and 4 1's, and the other side has 5 A's and 4 1's, so they match in terms of 1's, but this side needs 5 more A's for it to each have 10 A's. So I'm going to give it a 5A plus. And now we have 10 A's on both sides and 4 on both sides, and this problem works, it matches. So a big takeaway for me from this video is that if we have two terms that have the same variable and the same exponent, we are able to combine those like terms to create one term instead. If you came away with any other big thinking points from this video, go ahead and add those to your notes as a closure activity. And after that, this lesson's over.